Thanks for having me for this conversation. My name is Jay Jaganesh, based out of Bangalore, India. I am heading technology and products for Harman Digital Transformation Solutions. Harman is a fully owned subsidiary of Samsung, and Harman has three key business areas. One is automotive and manufacturing, where we design in-car experiences, digital cockpits, etc. The second business of Harman is audio, lifestyle audio. You must have used brands like JBL, Mark Levinson, etc. These are all brands. And the third division, which I represent today, is Harman Digital Transformation Solutions, where we build solutions and offer consulting services to our customers, primarily in the area of engineering, R&D, and services. Today, we will discuss our journey about leveraging and building, most importantly, building private domain specific large language models, and how we leverage AWS in the process is what we'll cover today. And we'll also have a couple of demos as well, so that you get a feeler about how these things look like. We'll start with an introduction about generative AI and what we see as emerging key trends in the industry and where we believe significant enterprise value can be generated. We will look at private large language models and why they are important from an enterprise point of view. We will talk about two instances of private large language models which we have built. The first one in the healthcare space, we call it Health GPT. And the second one, we are building a generic horizontal private large language model. We call it Forecast GPT, which can forecast regardless of the data sets we are looking at. And we'll also discuss some steps to build private LLMs. And of course, we'll have a couple of demos towards the end. If you look at this field of generative AI, this is fast exploding, and we don't need to, it's very, very difficult to keep track of emerging trends. But having said that, there are certain generic trends we are seeing emerging, which are getting stabilized more or less from an enterprise point of view. The first one is the models are becoming more and more complex, even though there is a significant trend towards smaller models, but we are definitely seeing larger models being more powerful and more customized models emerging. Multimodal AI, where we are combining text with images, videos, audio, is another trend we are seeing, where we are not just analyzing any one data sets in isolation. We are looking at multiple data points coming in from multiple sources. Transfer learning is being leveraged to learn from multiple training and learning models. Few short learnings are emerging, particularly in scenarios where we are faced with the challenge of limited data and we want to use that learning across multiple scenarios. Responsible AI, needless to say, given the fact that LLMs comes with their own complexity in terms of their inability to explain the underlying decision logic, this is getting more and more important, and enterprises want solid ways by which they can look at bias, they can look at explainability, how they can actually adopt these in a responsible fashion. Bias and fairness improvements are ongoing. Privacy preserving models are emerging. We are also looking at enhanced language understanding. We can see a plethora of non-English languages, non-English large language models emerging across the world. So there is more action because the English language LLMs are only the tip of the iceberg. There's a lot in global languages we're talking about. And finally, private domain large language models. And that is what we're going to spend more time today exploring why private models are important for enterprises and what are we doing at Harman in this space. Now, if you look at private large language models, these are models which are fine-tuned on domain-specific data sets, right? Basically, when you're looking at building a private domain model, we start by looking at a foundational model and essentially fine-tune it and retrain it based on enterprise-specific data. Now, for those who are using any of the public large language model, like for example, ChatGPT or any of the models out there, or Gemini from Google, you must have wondered, can I ask questions regarding my enterprise or my data sets with that same model and get experience as similar to the one provided by some of these extremely sophisticated models like ChatGPT? It is possible by bringing in a significant amount of data to these sources of analysis. At the same time, enterprises want significant control over the cost, right? Because many of these services charge you by the number of tokens, and many of the times enterprise data is so large that restriction on the tokens which can be which are available becomes a bottleneck. Also, there are significant specific requirements which enterprises have, right? Which means that you're looking at specific scenarios where there can be sensitive data which many enterprises want to manage and control in their own environment. There is a need for reducing hallucinations because you want to be able to reduce hallucination as you progress, and of course reduce bias. And most importantly, you're looking at a way to optimize and reduce costs throughout this entire development cycle. This is precisely where private models or private domain specific models come into play, where you can actually build a model, customize a model, fine tune a model based on your enterprise data and specifically answer questions which you are most interested in. And that is what we are going to talk about today. Now, there are several interesting trends if you look at private large language models. One interesting trend, one specific trend is industry specific customization. And more enterprises are looking at how can you actually build a private model specific to the data which I have in my enterprise premises. So this is something which is getting addressed by private models. Increasingly, there is a need for privacy and data protection because we are looking at enterprise critical data and you don't want this data to go to any third party systems. So that is a significant trend in this entire space. We are also seeing interesting trends on federated learning and edge computing because more and more processing, more and more data is coming in from edge devices. Responsible AI I spoke about. And then there are, of course, trends around multimodal capabilities of these models because currently a lot of the private domain models are just looking at text as a source of data, but increasingly we will see more and more of multimodal capabilities for these data sets. And finally, some few trends on global language support where you need these models to support more and more multiple languages from across the world. Now, this is a research we borrowed from Gartner and we added a few flavors based on what we see as interesting recommendations from our research. Now, if you look at this Gartner chart, you on the extreme, this is the build versus buy chart, right? On the extreme right side is build, where enterprises build everything from grounds up, which is an extremely expensive but a very valuable proposition where the enterprise builds everything from the foundation models upwards, right? So these are a domain, where typically the extremely, forward-looking enterprises who want complete control over everything, and they, of course, deep pockets play. On the extreme left side is where you have a completely, buy model where you're only dealing with APIs or service providers, but you have very little scope for competitive differentiation because you are dependent upon the API and you're not able to customize anything which is inside the black box. What we recommend in Harman, based on our consulting engagement with the customers, is use a recommended approach, which is the middle red highlighted box, where you leverage your engineering expertise, build a small AI ML team, which can play in between the extreme build and buy. And what we recommend in most enterprises is based on their level of maturity, their ability from a cost investment point of view, and their expertise of the technology teams. If you look at something like a private large language model, they come under the second last column on the right side, which is essentially about generative AI models via fine tuning. This is the domain we are going to discuss more today in today's discussion. And whether to buy, to build, or anything in between is a function of cost. It's a function of domain knowledge. It's a function of how much of security and privacy controls you want in place. Are you able to control the model output? And finally, are you able to implement, from a simplicity point of view and the ability to manage it, right? So again, this diagram sort of overlaps with the previous one I spoke about, where we are recommending a path in between for enterprises depending upon their ability on the dimensions and the decision factors on the left side. Now, Let me come to specifics of what we built. The first private or domain large language model, which we built almost a year back, is called Health GPT. Right now, healthcare is a very, very complex field with large amounts of data, extremely complex regulatory environments. At the same time, it ripe for disruption, right? Because of the fact that there is so much of data out there in the enterprise, in a healthcare value chain, enterprises are looking at ways to empower healthcare professionals, researchers, etc. That's where we identified as a problem area, and that is precisely what we built using Harman Health GPT, where we built a solution which can answer very, very complex and intricate questions, and with extremely deep domain knowledge. Right? So, in short, we built something like a public large language model, customized, built completely using open source and customize it based on enterprise data. Right. So the model has constant learning ability. It provides the end users with complete control of the entire life cycle of development. It provides complete control over the cost, privacy, and security of data. And enterprises can ask extremely intricate questions to the model. For example, on the left side, bottom, I put a question about a sample question and the answer given by the model. We are also building several differentiators into this entire Harman Health GPT. This is built completely on AWS Jumpstart, right? So this is built using the AWS Jumpstart environment. We initially started building the first version of Harman Health GPT was built using Falcon 7B model, and further down the line, we have built a new version which is built on the Llama 2 13B model as a fine tuning framework. So we have also built automated large language model evaluation framework, because it is not just plonking in a foundation model and putting in all your data. You need mechanisms to control the entire life cycle of model development, and that is why we have built this is where we build the entire framework for managing this entire life cycle. For health GPT specifically, we looked at three disease conditions. We looked at cancer, we looked at immune diseases, and we picked up heart diseases. And we looked at data which is clinical trials data. As you know, clinical trials data is extremely detailed, and we picked up this data to fine tune and build this entire model. On the right side, you can see the fine tuning data set, almost 130,000 records of Q&A data sets, 52 plus hours of training. Most importantly, this team which built it was not just a technical team. You need extremely strong business and domain experts. So we even have physicians, actual doctors in our team, who can curate it and created a golden data set of 200 plus question and answers, which was extremely critical for us to further build based on this gold data set using our data generation framework. So essentially building a large data set based on learnings from that Q&A to essentially explode and building more large data sets. We used clinical trials as a domain because we got high quality data. Because as I said, the data quality is extremely critical for building any any endeavor of this type, and therefore we looked at a domain where there's high quality data available across the board. Now this is a screenshot of the Harman Health GPT. You can ask various types of questions. We have built an end-to-end fine-tuning framework, which is very, very important, because this is not build one and forget it. This needs continuous updation. It needs continuous refinement, because the data is changing. The clinical trials data is published on a regular basis. So we need a reusable, repeatable framework. So this is where we build an end-to-end repeatable fine-tuning framework. Like I said, we need extremely high quality data. We ended up building a data generation framework. We built a large language model evaluation framework, extremely critical, because as you all know, that large language models are prone for hallucination and all the other challenges related to that. So we built we built guardrails, we built hallucination control factor, we built cost optimization modules so that you can actually optimize the amount of cost you're incurring for building and running the models, and of course various other related things. This is how the fine-tuning framework workflow looks like, right? You have the extreme left side where you have data coming in from a reference raw data set, and of course, a fine-tuned data set, and everything in between here built on the AWS Jumpstart architecture. I'll come back to the Jumpstart architecture in a minute. Before I'll just quickly jump into the demo, and then I'll come back to the architecture itself. I hope you can see the demo screen here. Uh, this is the Health GPT interface built on our chatbot. So basically, you can see that as a decision maker, it's an interface. You can actually ask questions. So there are some pre-populated questions out here. So I'm just choosing one of these questions here, and as we speak, the engine is going and hitting the fine-tuned Llama 2 model at the back end, and it is giving you the result. Now you can see how soon you got this entire result, right? So this is, you can actually play this and have an audio played for this answer. There is also feedback mechanism for thumbs up, thumbs down. So this goes into improving the model. We have also built in elements for retrieval augmented generation. We can control the tokens, we can control the temperature, we can control the topi, etc. Now I ran this first question with RAG off. I'm just switching on RAG, and now I'm running the exact same question, right? So this is the same question I'm running at this for the same, the same question running with RAG on, right? So the engine is running in the back end. Now you can see the engine has run. The answer is similar, except for the fact that it is also giving you the references from which the data is being fetched, right? So similarly, you can increase the tokens, you can control the tokens. If you make it 400 or 500 tokens, you can see a much longer answer. I'm just switching into RAG and I'm running the same question with almost double the number of tokens. And you can see the engine gives you very, very sophisticated answers, which are much longer and more detailed answer. Yeah. And the next one is guardrails and controls for guardrails, which we have built in. The key thing here is you want to control for toxicity. Right now, I put toxicity as off. You can always switch on toxicity so that if there is any objectionable content coming in, the engine will control it. We also have controls for PII. So if there is any PII data hidden in the data set, it will not be visible for anyone outside. You can also check the context boundary. And of course, you can also, we have also pre-built the prompt injection attacks. If somebody is writing some objectionable ways by which of hacking into the system, that is also controlled. You can also get insights into this entire data set. Where is the data set coming in from? What is the type of information which is out there? And of course, most importantly, we provide benchmarking numbers. So at any point of time, you can actually see how the data is benchmarked against some of the best practices. Let me go back to the PPT and cover one more private large language model before I come back for any Q&A. Now, I spoke about an industry-specific large language model, which is healthcare, and that model essentially can be extended to any industry. It can be extended to manufacturing, it can be extended to industrial, communication. It's all a question of how much of data, how much of quality data you want to bring about for fine-tuning this model. The next one is Forecast GPT. Forecast GPT is a general purpose forecasting engine. Now, you are all faced with scenarios where you have tremendous amount of data and you end up building a forecast model for every single data set. Extremely challenging, extremely time consuming. And since the data is changing on a regular basis, you also want the forecast models to be updated. Extremely difficult task. So what we thought of building one forecast model which can do a multi-purpose job of, regardless of what data you expose the model to, the engine is able to run forecast for you, right? So this is exactly the problem where we have trained a forecasting engine and built a forecasting engine which can learn from which is learned from a large amounts of data from various time series sources, and regardless of the data it is exposed to, it will give you the result. Again, built on Amazon Jumpstart. Here we use the Mistral 7B instruct model. The engine has been trained on large amounts of data from weather, traffic, sensors, power consumption, web traffic, etc. And the engine has learned from all this data set. Now, regardless of which data you expose this engine to, the engine is able to run very effectively, the forecasting results for you, right? So I'm going a bit fast because I wanted to spend a couple of minutes on the demo and then spend some time for Q&A as well. Very similar in concept to the previous health GPT demo. The only difference is the data set, the fine-tuning records. The previous one was more of clinical trials data. In this case, we looked at extremely different data set that is completely unstructured. This is completely structured, more time series data coming in from various sources. Everything else in the middle remains the same. We are leveraging our data generation module. We leverage our automated large language model evaluation module, and of course the optimization and deployment module. This is the architecture behind it. So this is where we are leveraging Jumpstart, be it Jumpstart for managing the model. We are using open source model, like I said in the beginning, and we are using all the basic functionalities of AWS for the entire end-to-end manipulation of the model. I'll come back for any Q&A. Before that, I'll quickly walk you through the Forecast GPT demo as well. There are two demos we have built for Forecast GPT. The first one we built is a scenario where most enterprises deal with, because we all have dashboards, and and this is typically what you find in most enterprises, where you have Click dashboard, Power BI dashboard, Tableau dashboards, you name it, right? So many of the times you are figuring out, historical data, how does my future looks like. So this is an example where the blue, or what you see in blue, is all historical data, and what is the red, what you see in red, is what the model is predicting, right? So basically you can choose the demand by week, you can choose the demand by month, or you can choose by quarter. All you're choosing certain parameters here, and the engine is actually giving you what you see in blue is all past data from which the engine is learned, and what you see here in red is what we are predicting based on this data. You can have monthly predictions, you can have weekly predictions, you can have predictions by demand, and various other parameters up to you, right? So you can actually also choose bi-weekly predictions. You can also modify various other things, right? So I'm just showing you a bird's eye view about demand prediction, but you can actually go for any of these parameters, country, region, etc., all of this you're able to change and predict. So it's one model, one forecasting model, which can solve multiple problems for enterprises. One more example I want to specifically call out, a scenario where enterprises don't want to use it with a pre-built solution dashboarding option. So here you can actually choose a certain business for an enterprise. Let's say you're a manufacturing company in the automotive space. I'm just choosing one of my business units here, and while it loads, I'm choosing a sub business unit. I'm using a business unit here, and I'm also going one step next, and I'm choosing a specific product for which I'm looking at. So I'm just doing a run forecast GPT model. So when I do a run forecast, it's actually looking at the historical data from various sources, and it is creating a forecasting on the right side. So you can see what you see here is blue is what historical data, and what you see in amber is what the engine is forecasting. Not just that, the next interesting one we have also built is we built something called commentary. Commentary is a very, very interesting one, where this graph and chart will be very interesting for someone who knows the business, but he or she may not know how the engine is, how to interpret this entire data. So the commentary is where you can actually run questions on this model, and I'm just writing something called explain the ongoing trends, right? So I'm just running this query, and while we see the engine is actually running a commentary at the back end, and it is trying to look at what the prediction the engine has done, and it is actually creating a summary explanation of what this data is all about. While it is running, I actually missed showing the commentary in the Click dashboard previously, but this gives you a flavor about what you can actually show as a commentary to explain the forecasting model. Wait for a couple of seconds while this runs. While it is taking its own sweet time to run it, what I would suggest is let us have any questions running in the backend, and while while this loads up, I'll come back here and show you the results as well. Over to the team for a Q&A for this.
Hey, thanks, Dr. J, for that. I think it was amazing to learn more about the health GPT and also the forecast GPT.
Yeah.
I don't see any questions in the chat, but I had few questions just in general. These are some of the questions we generally expect when we are working with domain-specific LLMs. Like one, how do you measure the impact and ROI of these LLMs for your product and business?
Yeah. So before I answer, you can see that there is a response which has come in. The response actually is very detailed, right? It is giving you a simple response about what you see as product trends, and it is also giving you an extremely detailed response, right? So if you are a novice user who doesn't know what this data is all about, it gives you an extremely detailed explanation. Okay. Uh, the question which was about the utility of this private large language models. Is that the question specifically?
Yeah, the impact. How do you measure the impact and the ROI from these LLMs for your
Yeah.
products and business?
So there are multiple ways by which you can measure the impact. The first one is how well you are able to impact some of the matrices we discussed in the beginning. It could be matrices for customer experience, it could be matrices for operations improvement, or it could be matrices in terms of how are you able to manage your risks. Depending upon the type of scenarios, you can essentially look at the utility of these models, right? If you're able to run your operations better, faster, cheaper, looking at incidents in the past, you are able to run a private model and say, if I'm able to resolve a query for a customer within a few seconds rather than wait for a few hours, right? That is a benefit for the customer. A customer satisfied customer at the end is one of those matrices. It could be operations. Let's say there is a system outage, which you are able to predict based on certain parameters. And if you're able to prevent that outage, that is again a benefit, right? So it depends upon case to case basis. And broadly, you can look at some of those patterns based on which you can look at what benefits you want to work out. So it will be very, very use case specific.
Got it. Thanks for that. So we have a question from Hariharan. So it's a large one. Actually, let me quickly read it. We have often noticed that time series foundation models have still quite a way to go in terms of performance. It usually follows the local trend, like the example shown. Secondly, the traditional forecasting methods often perform on par or better. So the question is, do you see any major improvement in performance with Forecast GPT?
Yeah, so we saw significant. I didn't cover the details about performance. I covered the details of performance for Health GPT. Uh, but if you look at the Forecast GPT model, it is far outperforming the traditional models, the traditional forecasting model like Arimas, Arimax. So we are able to comfortably, very, very hands down, beat some of these traditional models. So our numbers are, I have numbers to support this statement, but these are still early days. These models are only going to get better over a period of time.
Got it. And the second question is there any publication comparing the performance with other TSFMs like Chronos, Time GPT, etc.?
So yes, we have detailed benchmarks, and this is something which we constantly track. So absolutely happy to share on a separate forum.
Great. We have another question from Kamal. It's really interesting to have one view and choose GPT based on domain. How are we managing the separation? Is it separated based on multiple endpoints pointed to one view?
I'm assuming that how do you separate the underlying fine tuning data set? If that is the case, then it can be extremely use case specific. A model built for clinical trial data could be different from the model built on, let's say, EHR data or data about some of the other, let's say, manufacturing supply chain data, or it could be quality control data in the shop floor, etc. So one of the ways by which you can segregate is based on the type of data and the use case you're trying to solve.
Got it. Think we are almost done on the time. Thank you again, Dr. Jay. It was an amazing presentation.